In this video we look at binomial distributions again, and particularly we look at the mean and standard deviation. Now remember, the formula for binomial probability is fairly complicated, and here's the formula itself. And the key elements here, of course, is that x is the random variable that counts the number of successes. K is the actual value of the actual number of successes that you're hypothesizing. P is the probability of success, and N is the total number of trials. Now, one of the reasons we focus on binomial probability is it's very common. A second reason is because when you have a large number of trials, it becomes the normal distribution, the bell curve. And a third one, the reason we work at it, start with the binomial distribution, is the mean and standard deviation is really easy to figure out. So for a binomial distribution, the mean is defined as n times p. And the standard deviation, which is usually a fairly tedious calculation if you need to do it by hand, in this case is very easy. The standard deviation is just equal to the square root of n times p times 1 minus p. Now what is n, p, and 1 minus p? N is the total number of trials. P is the probability of success. And 1 minus p then will be the probability of failure. So let's just do a quick example. In this case, let's have the trial to be to flip 7 coins and count the number of heads. Let a success be defined as a head. And let's find the probability that the number of successes is equal to exactly 3. To find this, we would of course need to use the formula, the binomial probability formula. And it's not hard, but it does take some work. But if we want to just find the mean of x, it's much easier. So what does the mean of x mean? The mean of x means if you flip 7 coins, on average, how many heads would you expect to get? And that's just equal to n times p, where n is the number of flips, total number of flips, so that's 7. P is the probability of success. The probability of getting ahead would be 1/2. So your mean would just be 3.5. And your standard deviation is not that much more complicated. It's n times p times 1 minus p, and it's the square root of that number. So this would be the square root of n is 7, and p would be 1/2, and 1 minus p is also 1/2. So that's 7 times 1/2 times 1/2. 1/2 times 1/2 is 1/4, so that would be the square root of 7/4. And you could simplify that to the square root of 7 over 2, or you could just plug it into your calculator. Oftentimes in statistics we like to use decimals. And you get about 1.32, and that would be the standard deviation. Let's do another example. This case, let's roll a dice. And let's say our success is to roll a 1. And what we want to do is we want to roll 8 dice. Now, a natural probability then would be to say, what's the probability of rolling a certain number of 1s out of 8 dice? And that's what you'd use binomial probability formula for. But here, instead, what we do is we want to find the mean. So what would the mean be? The mean would be defined conceptually as if we roll 8 dice, how many ones would we expect on average? And the formula would just be n times p. N is 8, and p is 1/6, so it's just 8 over 6. Or another way to say that would be 4 over 3. You usually like to do this as a decimal, so it'd be 1.3 repeating. So about 1 1/3 ones is what you'd expect out of 8 dice. Now the standard deviation. The formula would be the square root of n times p times 1 minus p. So that's the square root of 8 times 1/6. Now 1 minus, if p is 1/6, then 1 minus p would be 5/6, right? The probability of not rolling to 1 would be 5 out of 6. And here you have the square root of 8 times 5 is 40 over 36. You could simplify that, but I think a decimal would be fine. That's 40 divided by 36, and then you take the square root of that. And you get approximately 1.05. And that would be the standard deviation. And that's how you do mean and standard deviation of a binomial distribution.